I'm all for sending spacecraft to Mars. And we're not in the 1970s anymore with the Apollo program. Our technology is such that the machines can do the job much faster, give us more data for a whole lot less money than sending people. So I see no reason to send people to the moon or send people to Mars or any solar system body, because we can send a machine that'll get us way more science for a lot less money and a lot less time than we try to do with humans. But of course, within us human beings, we always have the desire to personally explore. So I understand why, hey, if I'm a billionaire, put me in a spaceship and let me go orbit about the moon, because we kind of love that kind of exploration. And we can send people to the moon. We proved that with the Apollo program. It's because we had people there for only a few days maximum. And for halfway there, they were protected by the Van Allen belt that surrounds our Earth. So they didn't get exposed to a lot of radiation. But if you're going to Mars, you're very quickly outside the Van Allen belt that surrounds the Earth. You get exposed to deadly solar radiation and deadly cosmic radiation. And also, you're in zero gravity. Well, Elon Musk has figured that out, that, hey, we're going to have artificial gravity. But the problem is, if you're in a small spacecraft with a long rod and a counterweight and you're rotating it to produce artificial gravity, is that you're going to have a stronger gravitational pull on your feet than on your head. And the human body is not designed for that. We have to experience roughly the same gravity at our head as we do our feet. Well, to make that happen, you got to make the spaceship, about 10 miles, like make it a large Coke can, where the Coke can is 10 miles in diameter. Now you can have roughly the same gravity at your head as your feet. But now we're looking at a really, really big spaceship. And even Elon Musk, with all of his money, isn't going to be able to build that kind of a spacecraft. Moreover, once you get into interplanetary space, the chance of being hit by some kind of tiny pebble or a piece of dust that punctures your spaceship, once that happens, everybody inside dies. And hey, to protect from the radiation, you're going to need about 15 feet of water or a foot of lead to protect you from that. Now again, you're looking at a really heavy spaceship. And hey, if the armor that protects that water or that lead gets punctured, all your water escapes and everybody on board dies. So it's like, we're not sending people to Mars. And even when we get to Mars, they can't live on the surface. They're going to have to live underground. And we've already done experiments. Humans don't do too well spending all their life underground. And incidentally, the environment of Mars is deadly for life. So yes, I would say that's not going to happen. Although, what I find interesting, and this really applies to the UAP phenomena, is we astronomers are seriously wanting to send spaceships to the nearest planet outside of our solar system. But we're aware we're going to have to go at least 1/10 the velocity of light. And when you're going that fast, you get hit by dust particles that can do a lot of damage. So for example, even as slow as 1/10 the velocity of light, which means you're looking at 43 years to get to the nearest planet outside of our solar system, if you run into a dust particle that's 10 times smaller than the period at the end of a sentence in 10-point type, basically a dust particle you can't even see, it's going to slam into your spaceship with the force of a baseball thrown at 100 miles per hour, multiplied by 19,000 times. Bottom line, you're not going anywhere unless you can avoid hitting even the tiniest of dust particles. Interstellar space is filled with dust particles, and so we astronomers have figured out the only way we're going to be able to get a spaceship to the nearest planet outside of our solar system is to make the spaceships extremely small and needle-shaped, so they have a chance of getting there without hitting a dust particle. How small? Well, the biggest one we could send is about the size of a matchstick. Better yet, make them the size of a toothpick and send 5,000 of them, because almost all of them are going to get destroyed by running into dust. But the odds are maybe we'll get 2 out of 3 out of those 5,000 tiny spaceships that'll be able to send us back some information. And of course, it's going to be just a flyby. With a spaceship that tiny, you can't slow it down. You can't land. You can't make an orbit around the planet. It's simply going to be a flyby at 1/10 the velocity of light. And so for a few seconds, we might be able to get some useful information we can send back to Earth. But that tells us the idea that beings are traveling to us from another planetary system, there's no way a spaceship bigger than the size of a toothpick is going to be able to traverse interstellar space, and even a bacterium is not going to survive in a spaceship that tiny going across interstellar space. The radiation in interstellar space will kill even the tiniest bacterium. So no biological entity can possibly engage in interstellar travel. That's really the theme of the new book we're bringing out, is that this ETH hypothesis, we're being visited by beings on spaceships, it's simply impossible based on the laws of physics. The only way it can be done is by entities that are not subject to the laws of physics like we are.